Identities. I don't know why I called it a lesson. It's not really a lesson. Anyway, let's get started. So let me start off with an equation. Okay. So we all know x squared minus 5x plus 6 equals 0. We all know that's an equation. We all know that's a quadratic equation, right? So I'll just, you simplify it, put it in brackets. But I'll just put out x equals 2 and x equals 3, right? Okay, so that is an I didn't mean to do that. That is an equation. Okay, so the thing is with equations is this equation is only true for these two values, right? So you'll only have that equation when those two values are that, right? So you're following along so far? And so an identity is this: 3x minus 4 equals 3x minus 12, right? So this one is an identity. And the thing is with identities is you can have many values for x. There's no set values for x like there is with this equation. So true for all values of x, right? So that's an identity right there. Okay, so what we do for identities in this paper, but prove that sin x over cos x equals tan x. Right? So let's just draw a right-angled triangle here, because these are functions. These are functions for right-angled triangles. So we've got C, got X, A, and B. So obviously this will be the opposite. It's the opposite, that's the adjacent, that's the hypotenuse. But we'll just put them in A, B, and C for now. That's pretty bad, A. Okay. Yeah, So I'm proving that sin x or cos x equals tan x. So sin x equals A over C, right? Tan x equals A over B. And cos x equals B over C. Okay, so when you're writing out the answer for this, you always have to go left hand side equals. You can work out from the right hand side, but it's always easier to just work from the left hand side. So you go left hand side equals sin x over cos x, right? And sin x over cos x equals A over C over B over C, right? We're just substituting in these two, right? Substituting them in to that. Okay, so that means that equals A over C times C over B. And if you don't know how I got that, it's simple algebra. So from that, right, you have A over C divided by B over C. But when you divide something, you just flip it around, right? So to make it a times, you just flip that around to C over B. Right? Simple algebra sort of going on there. Okay. And then, so then you cross these out, and then you've got equals A over B. And A over B is equal to tan x, and tan x equals sin over cos. So you've just proven that A sin over cos equals tan x, set tan even, just from working it out like that. And that's how you have to prove identities, basically. You just substitute in opposite, hypotenuse, adjacents into it, and then you get it. And sometimes it gets harder by using sec and the reciprocals of sin, cos, and tan, but we'll get onto that later. But it's pretty straightforward stuff. Okay, cool. Move on to a second example. Prove that cos x over sin x equals cot x. Okay, so same as for left hand side equals cos x over sin x. Okay, and that equals b over c over a over c. And that equals, so basically it's really easy, you can just cancel those out, except I would always put it into, just so you know that you then bring that on top. So then that equals b over a. Now what does cot equal? Right? Now if you remember, cot is the reciprocal of tan, so that means it's the opposite of tan. And what was tan? Tan was a over b, right? So then cot would be b over a, because it's the opposite, right? They just go and switch. Simple stuff, right? So cot x equals b over a, and cos over sin equals b over a. So you've just proved that identity. It's pretty interesting stuff when you really get down to it. And now we have our last identity. Prove that tan x times cos squared x minus cot x times sin squared x equals 0. Okay, so again, left hand side equals sin x over cos x, because that's tan. Tan equals sin x over cos x, as we found out in here, right? You always want to make sure you do everything to sin x and to cos x. You never want to do anything to tan or any of the reciprocals. If you do it to sin x and cos x, it makes everything a lot easier. Okay, so we've got left hand side equals sin x over cos x, right? So that's the tan, times cos squared x, which is cos squared x, because over 1, right, minus cos x over sin x times sin squared x over 1. And we're doing cos squared and sin squared because it's a squared. It's easier to keep it in that format. And then you can simplify it from there to sin x and cos x. So from that, we just cross multiply. So we get, okay, so you know how you times a fraction. So you just get sin x times cos squared x over cos x. And now that's, if you didn't know how I did that, when you're multiplying fractions, times like that. So you've got that. You got sin x times cos squared x over cos x minus, let's do the same thing over here, cos x times sin squared x over sine. I say sin a lot, but it's sine, but I just say sin anyway. And so since we've got the squared, we want to simplify. So there's two causes, right? So you can take away one of them by taking away the squared, and you take away that one. It's a simple algebra. And the same here. So you can just cross them out. So we are left with, just do an arrow, we are left with, we're just going to go up here. So we're left with sin x times cos x minus cos x times sin x, right? And now just look at that. What are we trying to find? We're trying to find it equal to 0. Well, sin x times cos x is cos x times sin x, because they're one thing, you know? Just imagine them in brackets. So they are one thing, so they are the same thing, you know? So that, in turn, equals 0. So we have just proven left hand side equals right hand side. And it might be just useful on your test to write that, as so the marker knows that you have proven it. So that's all for trig identities. And that is about it. And I guess the only other thing you need to know is, remember, is, you know, that's an equation. You know, equation is where x has set values. Well, you know, the variable has set values, and an identity is where there are no set values. There can be many different types of values. I mean, for the example I shown, you could go up probably into the thousands, and this would still, you could probably still make it so they equal each other. Okay, so I hope that cleared things up on identities, and as I said, we'll be going into harder ones in another video. Thanks, guys.